All right, Sunny, I'm glad to be able to get together once again and have another conversation about aquaculture. I know we've got some positive feedback from others and thought we'd just kind of continue our conversation. So in case anybody's missed it, you want to give yourself an introduction real quick and I'll do the same. And then
Mm,
I wanted to talk a little bit about the virtual RasTech conference actually to start.
mm,
But
mm,
let's make sure people know who you are and who I am, and then we'll get into it. So.
mm. Yeah, so my name is Sunny, as it's always written on the tagline too. And I'm aquaculture expert with background in the fish feed. And of course, I'm just concerned about the sustainable food production. And I think aquaculture is the sustainable way of producing seafood, and people need more seafood, and that's why all my efforts are about this on Aquaculture Tribe to bring this awareness and to improve the practices which are in business and on the operational level. And also I normally now try to connect a lot aquaculture with sustainable way of doing things. So you might have heard about this ESG frameworks, and I think aquaculture is a solution for a bigger scale of producing food for years to come, for decades to come, for centuries. And we are here we have to fix those things. If we can't do it, we should talk about it. So
Yeah.
please go ahead.
Yeah, I appreciate that. And so I'm Brian Grochowski. I'm with Aquaonics UV. So we do disinfection systems related to the aquaculture industry, but of course, a lot of other industries as well. But appreciate the opportunity to learn from you and learn from one another about aquaculture, as disinfection, of course, is just one small piece of the operation, of course, but an important piece. But I did think today, one thing I wanted to talk about initially, and then we can just kind of see how the conversation goes. I know we've talked a lot about fish feed and
Mm,
water quality in the past on different
mm,
conversations. Um, since our last conversation, I think RasTech, they had their virtual online conference, which included actually really a lot of really good webinars. So if you haven't checked those out, there's probably about a dozen of those that are available online. I
mm,
think that you still have to register in order to view those, but a lot of really good 30-minute webinars that are worth checking
mm,
out.
mm,
And the one that I wanted to maybe chat about a little bit today, that you and I talked about a little bit offline, was the one that Chris Good put together, talking specifically about disinfection, actually. And of course, maybe that's why that one's a little bit more interesting to me, because it's kind of in my wheelhouse, so to speak.
mm,
But I thought if it's all right, I'd give a super quick summary, kind of the 2-minute summary of his really good presentation, and then we can just talk a little bit about some of the aspects of that, if that's all right. But what they did as part of his research is that they did basically a survey of 16 facilities throughout the US and Canada, existing RAS operations, to evaluate their disinfection practices,
mm,
what they utilized, how they monitored for it, what sort of outbreaks they had. And these were some of the findings that they had. So all facilities, of course, agreed that disinfection and having a disinfection protocol in place was important, but only about 20% of those facilities had what they called a validated protocol in place,
mm,
which I think
mm,
is important. Um, it also mentioned that only about 60% of those facilities had confidence in the disinfection protocol that they had, and less than 60% kept any records of the disinfection
mm,
that they had,
mm,
which I thought was interesting. While the disinfections that were chosen were based primarily on efficacy and performance, it was mentioned that only 62% or so of those facilities actually did disinfect after every product cycle. And it was suggested that
mm,
oftentimes that was a matter of time, just not having enough time to go through that between production cycles, which frankly I thought was really interesting, that I'd like to talk to you a bit about.
mm,
And lastly, of the 16, 5 of the facilities actually had outbreaks. I think it was during the previous 5 years,
mm.
but they were non-viral. But
Yeah.
nevertheless,
Mm,
it was Vibrio, Yersinia ruckeri,
mm,
and Aeromonas salmonacida were the 3
mm,
organisms that came up in those 5 outbreaks,
mm,
which I thought were interesting. So if you think you've got 16 facilities over this 5-year period of time, and at the end of the day, you have these 5 outbreaks. Now, I don't know if it was 5 out of 16 had that, or one facility had multiple outbreaks.
mm,
It wasn't clear on that. But I
mm,
thought it was interesting where, in theory, you've got a disinfection protocol in place that you've chosen based on efficacy, but you still have problems. So I was wondering, just based on your experience in aquaculture and other facilities you've worked with, how common is that? I mean, I felt that I was a little bit surprised to see, in my opinion, a fairly high rate of outbreaks, because at the end of the day, even if I ignore the fish aspect of it, from a profit and bottom line aspect, you know, those sort of outbreaks are likely going to cost money, and there are ways to mitigate those risks in many cases. So just wondering what your comments are from his presentation.
Yeah, I thank you for sharing that presentation. I went through that and it was quite interesting. And I saw this project Control Aqua before. I mean, once they started, I've been kind of following it up on the internet, and it's very good that they came up with this proper stat on this thing, which also gives the state of the outbreaks in the facilities and its connection with disinfection. It's directly related to biosecurity, definitely.
Right.
So, of course, this, I mean, outbreak is never a good thing it's a common sense, because once you have the outbreak, and let's say if you have outbreak after 3 months or 4 months of your when your fish is 3-4 months old, and you have the outbreak, then you have to disinfect the whole facility again, and then you have to redo everything. And of course, the financial cost of this aspect is quite a lot, because if you're talking about trout and salmon, which are quite expensive, even their smolts are quite expensive compared to tilapia, for example, or shrimp, for example. So then, of course, the economic cost is quite a lot, and also, of course, the cost on the environment is there, the cost of like the people, also the emotional well-being of the people working in the facility is never a good feeling when fish dies. So, and also the economic cost, of course, is definitely a key parameter here. So, of course, there shouldn't be any outbreak in the ideal scenario. And these outbreaks are normally quite costly whenever they happen. So, for example, in Norway, in the small facilities, you have quite a lot of amount of fish. You have, I mean, millions of fish. So once, if the outbreak happen and you have a lot of loss, that's you're talking about millions of dollars even. So this is really, of course, a big issue, and it's not like something which have happened overnight, for example. So one of the things which is very interesting in this outbreaks is that you may see that this thing has happened, for example, today, but what are the events which has led to this huge mortality? So this is also a very important point.
Yeah. I was just curious, this from your experience, you know, when you look at even these couple of outbreaks, you know, again, it was kind of enlightening to me to some extent to see how many of the facilities, although they had a protocol in place, you know, it wasn't what they considered to be validated, wasn't something they had a lot of confidence in many cases, and wasn't something that they monitored very regularly in many cases as well. So when you've got those elements in play, and then eventually, let's say you do have an outbreak at a facility like that, how easy really is it to trace back what happened, so to speak, or where that outbreak may have come from? I would imagine if that's kind of the mentality or the status quo, so to speak, in a facility like that, it's got to be really hard to track or trace back where that came from. Would you agree, or what's your experience there?
Yeah, no, but normally they have normally the once this happens, at least in Norway, they have a proper system that whatever happens, you have to report to the authorities, and you go through the all due process. And normally these type of reasons that why it happened are actually normally out. It's quite public. Once it happens, for example, if you have some infection or some viral disease or some bacterial kind of outbreak in the facility, so that's quite open knowledge. It's not that you can't hide it by law. So it's very open, at least in Norway. I don't know about the US, but here it's quite open, this information. which are the disease-causing agents. So this is quite open.
Yeah, yeah. I thought it was interesting too, just again, to think about those organisms that were detected in these different facilities. Again, when you think about selecting a single disinfectant to try to kill all viruses and all bacteria, you know, again, certain organisms are going to have higher susceptibility to chlorine, for instance, than others are going to have. You know, some are going to be slightly chlorine resistant. And so I think it was kind of interesting when you looked at his study or his survey, you know, it showed again that chlorine was the top disinfectant that was used at these facilities. And I would say probably not surprisingly, you know, that's a good reason why you probably don't see a lot of viral outbreaks, because generally speaking, viruses tend to be easily disinfected with chlorine, whereas certain other bacteria have some level of chlorine resistance. What we've seen in other industries, and we're seeing a little bit more in aquaculture, I think it'll be an increasing trend, is the tendency to do more of dual disinfection. You know, just as an example with UV, some viruses, while there's no organisms that are resistant to UV, some organisms do require much higher UV doses or higher energy to inactivate them than others. Okay. So when I think about something like certain viruses like IPNV in salmon, you know, it's not resistant to UV, but it requires a very, very high UV dose in order to inactivate it. Where you look at like these three organisms that they had outbreaks of here, you know, Vibrio, Yersinia ruckeri, and Aeromonas salmonicida, all three are highly susceptible to UV disinfection. So it doesn't take a lot of UV energy or much UV dose to inactivate those bugs. So we could see in an application like that, it would make a lot of sense to have some online disinfection to try to inactivate those organisms, again, as long as you can get them to flow through the UV system. You know, one of the big challenges with using UV as compared to some of the other chemical oxidizers that was mentioned in his presentation, of course, is there's no residual with UV, you know. So if you can't get the water flowing through the UV system and there's pockets or areas of low flow where those organisms are going to attach to as biofilms or whatever else, then, you know, you could potentially have a problem there. But in a system that's well designed where you're able to get flow through the UV system, some sort of combination in the case of something like chlorine as a primary disinfectant and UV as an online disinfection technology would really make a lot of sense for those organisms in particular. So just thought I would kind of throw that out there.
Yeah, that's quite positive, isn't it? I mean, if you don't have the residuals, that's also quite positive. And then you also don't, I mean, this is, as long as you are telling that it seems like this is like non-chemical way of disinfecting. And then you are also saving water in a way. If, for example, you are also, and after, if you are using chlorine, then you are also discharging this water to the public waters or treating it and then still throwing it out, but still it's not 100% clean. So this is very interesting, and that if you can do it in a more greener way and in a sustainable way, that's actually quite a better way. But I don't know how you know, because thinking loud about this thing, there probably could be some hazards of using UV as other technologies as well, I think, because it might be not safe for the human beings exposure. It is like also, I don't know how the fish react to it.
Sure.
Or where do you put it? What is the process which goes for the installation? I'm sure it's not like fish is exposed to it.
Right.
But in which are the areas normally you put in? Can you explain a little bit about like what could be the downsides of this?
Yeah, sure. So let's talk about the negatives first, so I don't sound like I'm too biased, right? You know, for positive or negative, you know, there is no residual post UV. So, I mean, the negative, of course, is if you don't have great flow going through the RAS system and you have no residual through this disinfection system, even if it is your primary disinfectant, then there's going to be pockets or areas that are going to promote microbial growth, especially if there's biofilms in that operation. Again, thinking about what Chris Good mentioned, you know, if they don't disinfect every production cycle, you know, if 60% of the facilities are unable to do that, then you're much more likely to have biofilm growing at certain parts of those facilities than you are at others that are both cleaning and disinfecting and have the time to do that. So with something like UV that has no residual, then that creates an increasing risk as organisms attach to that biofilm potentially. The positive, of course, is that because you don't have those byproducts that you would with chlorine or ozone in particular is one that pops up, then you don't get that bioaccumulation that you might get from certain byproducts in the fish or whatever else it may be. So, I mean, that is a positive that you're less likely to get that. I would say if there is a negative, I mean, again, I think how the UV system is sized for the operation is pretty important to get right up front. I mean, a UV system, it's not like chlorine or ozone or some of the other disinfectants where you just crank it up and add a little bit more. You know, you add some more energy or add some more light. It doesn't work like that. I mean, most of the time you'd have to change out the vessel. You can't just pack in more lamps or add bigger lamps. It doesn't really work that way. So you always have to think about highest flow coming through the UV system, worst water quality coming through the UV system, and most difficult organisms that you want to target. And if you get any one of those elements wrong, I mean, the flow rate's usually an easy one. The organisms, for the most part, you know what you want based on the fish species that you're growing. But the water quality is the tough variable. And I know that's why we touched on that in the past. If your solids increase from 10 ppm to 20 ppm, that has an exponential effect on how well the UV system performs because the solids not only block or absorb the light, but organisms will shield themselves behind the solids and make their way through the system. So you have to think about solids fluctuation, turbidity or UV transmittance changes. So as turbidity increases, light can't penetrate through the water quite as well. And then you're going to have a reduced level of performance because of that as well. And same thing with color, you know, so for operations that have more issues of color coming through the water, again, color is going to prevent the UV light from penetrating through. And while the turbidity might still look okay, the UV transmittance, which is what we really look at from a water quality standpoint, we see that as a decline in transmittance, which again has a direct result in UV system performance. You know, and talking about how it interacts with fish, because it isn't a closed system, you know, the light's not exposed to the fish, so there would be no adverse effects there. You know, there are some systems that are designed in what they call an open channel UV system, where essentially you think of a large trough where you drop in banks of UV systems, and there can be light exposure in some cases for individuals that are walking past those channel systems. But what we're seeing more and more, particularly in operation, of course, are more of these closed vessel UV systems, which in very simplistic terms, think of it as just a light in a pipe, you know?
Yeah, very good analogy.
Yeah, I mean, it's the technology is a lot more complex than that, but as a very basic, it is just kind of a really neatly designed light in a pipe, designed and with a lot more technology behind that. But
yeah, so if I have understood you correctly, excuse me if I have disturbed you, but if I have understood it correctly, you are saying that one of the positive aspect or one of the things you can actually achieve with UV is that you can decide are you going to harm the good bacteria or bad bacteria. You can like kind of have some parameters when you're treating this treating UV treating water with the UV with and you can actually adjust the parameters. Is that what you said?
Yes, I won't say that we can select between the good and bad, so to speak. You know, every organism is going to have a different level of susceptibility to UV. So some are going to require very high doses. Again, something like IPNV in the salmon industry, which is a big one, that requires a very, very high UV dose. So a lot of energy to inactivate it. Where other things like these other three organisms we mentioned previously that Chris Good pointed out in his presentation, those don't require a lot of energy, okay? But it's important to get right up front because if you were to select a UV system to target those other three bugs that don't require high UV doses, and then later find out, oh, well, this other organism is something that we're really concerned about, and it has a very high UV dose requirement, the UV light's not going to have really any effect on that organism, you know?
Yeah,
So
that's
there
very
is this
interesting.
balance. Yeah, there is
That's
this
very
balance.
interesting because, of course, if you use bleach or chlorine or formalin, for example, and these type of chemicals, of course, first of all, they are not good for the environment at all, definitely. But of course, they can kill then everything, even the good things. So in RAS, you have to have good bacteria being protected, and if you have the different this micron size on your treatment, then I hope that could be very interesting. And I think there are some companies who are already doing it commercially, as long as I know. But I'm not expert in this field, but I think this is really something very interesting.
Yeah. Yeah, I think, you know, we've of course been in this industry for quite a while. I mean, it's been probably 20 years that we've been providing UV systems into the aquaculture industry in general. You know, so over that time, we've obviously provided a lot of systems into this particular application. But I would say that, you know, what we tend to see is the industry still, I think there's a bit of a knowledge gap when it comes to the use of UV in these applications. Where does it fit? Can we use it as the primary disinfectant? And then again, how do we size it? Because I think there's a lack of understanding of the technology, and I think it's not uncommon for somebody to dumb it down at the end of the day and say, well, it is a light in a pipe, so why should we buy from this manufacturer or the other? It's both going to be just the same, right? And unfortunately, it doesn't really quite work like that. I mean, there is a difference between a validated UV system and a non-validated UV system, which I think I'll put everybody to sleep if I go through that in too much detail. But
it's quite interesting, and I'm sorry. I think I lost some connection with the outer camera.
Yeah, that's okay. I got you back now.
I'm sorry for that. So it's very interesting, Brian. This seems like this seems like quite interesting area also for aquaculture. I will say it from another perspective, because now aquaculture, like agriculture, is also facing a lot of heat from the authorities. It's also facing a lot of scrutiny from the customers, and we actually have to stay relevant. We have to adopt new ways of fixing the problems and the challenges we have. And we have to improve a lot with the practices we have in the industry right now. So, of course, I mean, this type of technologies, which you are also presenting, this UV technology, this is also part of the solution. It has its merits. For example, this is, in my understanding, if it doesn't take too much energy, of course, it's quite green. It's also non-chemical. It's also less harmful for the environment. So there are some merits, and I think we should promote such technologies. There is nothing wrong with that. I hope you understand.
Yeah, no, I appreciate that. I think again, I circle back to some of the points that Chris Good brought up in that presentation about effective use of disinfection. And I think the part of the nice thing of where UV might fit in is, again, maybe we'll get into that on another day, but there is a such thing as third-party validated performance tested UV. So where there was that gap in what he mentioned about only 20% of facilities had what they considered to be a validated disinfection protocol, there are UV systems that have already gone through performance testing and validation that meet that meet those guidelines. So you don't have to try to do that in-house work yourselves. I mean, that work has often been done by third-party engineering firms that do that sort of testing. And then same thing with the monitoring gap. I mean, the more advanced UV equipment has some self-monitoring involved. It does have monitoring equipment attached to it. It does have input-output so that you can pull information and data from it. So you can monitor in real time how well the UV system is doing. So for example, if solids increase, for example, and the UV light can't provide enough energy to compensate for that, then it will provide an alarm to let you know. So you can see that you've got a gap that you need to address, And again, as we've talked about before, how important that is, because if you don't catch it early, the downstream effect can be a lot more significant. And that's where these sort of outbreaks, I think, often may occur. So
that's quite interesting. I think we can take it in next time also. We can, because this was, I think it's hard to digest for many people, because
sure.
It's quite a lot of information. You have been very informative on this thing, and I think we will also learn a lot on this aspect of disinfection. And I hope more and more people adopt to this non-chemical way of doing disinfection. But of course, like every technology have its own, it has its downsides as well as the upsides. And of course, if you can design the systems which can cover the downsides and improve, I think this is really a fantastic technology to adopt for aquaculture, as long as I understood from your presentation on this thing.
Yeah.
So,
yeah. No, I think it's a good point. I think the other thing that we see is that there's also this question of pre-treatment. You know, if you expect a lot of variability in the operation as far as what your filters are capable of doing, or this issue like we talked about early on about overfeeding and the downstream effect. You know, UV is one of those things that if you have the issue of overfeeding and overloading of the filters, and you have more coloration or solids or things coming through the UV system, you know, you may have very well taken a UV system that works really, really well and something that is now just not doing much for you, you know. And so that control of the operation is an important piece, obviously. And I know we've touched on that on previous discussions as well. I know we only have maybe a few minutes left. I don't know if you've want to talk a few minutes about the ESG conversation.
Yeah.
As well.
So this is one of the things I wanted to discuss a little bit, is that you know, we at least we believe that seafood coming from the aquaculture is it's a very sustainable way and healthy way to produce the food for the planet for the future. But of course, there are some challenges. There are some challenges in sustainability, but I don't want to go into the feed and feed ingredients coming from the agriculture, you know, so I don't want to go into detail on that side. But I also just want to mention real quick that rather than taking the pressure and thinking that this is maybe against aquaculture, if we adopt to these new trends, and if we adopt to these new way of thinking, which are more environmentally oriented and thinking about sustainability on the larger perspective, we have much more to gain. And I think everybody have much more to gain on this thing. So this is, we can discuss it next time, maybe.
Yeah. Yeah, I think it's such an important concept as we think again about even just the future food supply, you know, outside of aquaculture. It's going to be so critical to see how the industry develops and what support it gets from different organizations globally. We saw some things recently too about some information that's been passed up through the U.S. government to try to get, I'm sure, some more funding and some more flexibility. So we'll dig into that.
But it's also very important to kind of do new things in this thing, and of course bringing new technologies into aquaculture which are more sustainable, doing practices which are more sustainable, also thinking about the governance aspect of the things. Of course, this biosecurity is directly related to that in many ways. So there are there are still the labor issues in aquaculture farming, for example. The sourcing of ingredients are very important. So these are very interesting aspects which we can discuss some other time. But I think today we are running out of time.
Yeah, that sounds good. Well, let's plan to do that. I appreciate again the chance to get together and talk. Always enjoy it. Hope it was useful to others as well. And we'll do this again next time.
Thank you. Thank you, Brian. Thank you,
Bye-bye.
Brian. Thank you. Bye-bye.